Good morning, everybody. Hope everybody's doing well. Today's lecture I'm going to fill you in on has to do with how operating systems work. So this is one of the sections for the computer science concept material that you'll be asked questions about on the next exam. So just to show you what we're looking at here, if you look at so just as far as test 3 is concerned, in class we did the beginning computer architecture and then decided to skip converting integers to binary, converting decimals to binary. I created a video on how the CPU works and also one on communication errors, parity bits. So today we're going to be talking about the operating system and some of the highlights on that. So let me bring us back to there. Okay, so basically the operating system is the way that the user can interact with the computer resources and the hardware. So the resources being both software and hardware. So that's basically the definition of an operating system. Now, what we're going to focus on are not simple operating systems like what you would use on your desktop or laptop, but we're going to focus in on operating systems that are multi-platform. That means that are used by servers, because those are operating systems that you're probably not familiar with. So in the world of servers and users and corporations and so forth, they may be using Unix or Linux or some variation on those. So we're not interested in a single user operating system because that's pretty simple and it's what you're kind of familiar with, what you use on your phone, Android phone, what you use on your Apple phone, or what you use on your laptop. So the focus is going to really be on multi-user systems. That means servers, because there's servers out there in the world, but there are many, many, many more people using those servers than there are servers. So for example, when you decide to do a Google lookup, you're communicating with a server, but also so is 100 other people communicating with that same server. So Google may have thousands of servers, but it has millions of people making requests of its software. So we're going to break this thing up into pieces. First of all, what is the CPU on this server doing, right? So a server is nothing more than a computer, a fast computer, and server farms are simply, 100 or 1,000 computers sitting in one warehouse. But each of those servers are serving multiple people. So how can a single computer, a single CPU, basically serve a whole lot of people? And the answer is that it takes each request and places them on a waiting list, which is called a queue. So, and each person is processed on a first come, first served basis. However, each requester, each person who makes a request, that means like you sitting at your computer making a request of Google, you can't get complete control of that CPU for as long as you want it because too many people would be waiting for way too long. So what you do get is a little burst of time. It's called a time slice. So you get a little burst of time, CPU time, and then the next person gets CPU time, a little burst of CPU time, and so on. Now, obviously, your request isn't going to be completed with a single burst of CPU time, which might be 1/10 of a second. You need more time than that. So basically, this process continues in a round-robin fashion over and over and over again, people getting little bursts of CPU time until your request is done. So if this happens, so if you have 100 people each getting a request of CPU time of like a tenth of a second, it could take 10 seconds to get your request back. That's a little bit of an exaggeration. Actually, the burst of CPU time is more like a hundredth of a second, and so it may take a second. So if a lot of people are making requests to that server, it takes a little bit of time. So this is known as a time sharing system. You got to remember that, right? So this is a time sharing system where one server shares its CPU time with a whole lot of clients, they're called, which is basically people who are logging into the system. So this slide is particularly important. Okay, so then the next question is, well, what about memory? How is memory used? Well, again, you have a single server and a whole lot of people. How is memory managed? So we could make memory really, really big to support all these different requests, but that would be unmanageable. Can't really create memory big enough to physically support 100 different requests of lots of different applications. So what do? What is done? Memory fills up, and at some point, applications are swapped out of memory to make room for new applications. So as requests are made, this swapping process occurs. That means applications that are not being used in memory are moved to a disk, and to make room for new applications in memory. So this is known as virtual memory. So virtual memory, this is important. Virtual memory is the appearance of more memory than is actually available. And how does that work? Through swapping. That means processes are moved from memory to disk, and then new processes are moved from disk back into memory. So all this is going on frequently, making it appear as if memory has much more room than it actually has. This is called virtual memory. So basically, servers use virtual memory to support many, many users, many applications, in fact, more applications than there is physical space for. Now, the implication of this is as you swap, you're moving processes out that are slightly bigger than the processes you move in. And this creates what's known as what I call Swiss cheese. In other words, you create holes in memory. So applications that move out are a little bigger than the ones that move in because they can't be smaller, because otherwise the new application wouldn't fit. So you get a whole bunch of little segments of useless memory. And at some point, periodically, these little segments of memory have to be combined in what's called usable memory. And that process is called compaction. Okay, so to review, these are the important things. You need to know, how does a server allocate CPU time? Through a time sharing system. What about memory? Memory is managed through swapping applications between memory and disk, and that is known as creating virtual memory. And to a lesser extent, as all computers do, the operating system manages all the shareable, that means resources such as CPU and memory, and also the non-shareable ones like printers, storage systems, and so forth. Okay, so that's all you need to know as far as, this is an important slide right here, as far as test number 3 is concerned, having to do with the operating system. All right, the next class will be creating a video that has to do with the sort of a brief history of programming languages. Have a good day. I'll be having class later on today at 1:30 for anybody who wants to come and ask me any questions.